Have you ever wondered what's going on inside that glowing box on your desk or that sleek tablet in your hands? It seems like magic, right? You press a button, and suddenly you're watching a video from the other side of the planet or talking to a friend who is miles away. But it's not magic, it's science. A computer, at its very core, is an amazing machine that is designed to follow instructions. Think of it as an incredibly fast and obedient helper. It takes information, thinks about it really fast, and then gives you a result. It can calculate, organize, and remember things far better than we can, which is why they are so incredibly helpful in our world today. Now, why are these machines so important? Well, imagine trying to build a giant skyscraper without a crane or trying to send a letter across the ocean in a rowboat. It would take a very long time and a whole lot of work. Computers are like our modern-day cranes and speedboats for information. They help us do huge tasks quickly and accurately. They connect us to a world of knowledge. Alright, let's dive inside the computer case and meet the superstar of the show, the Central Processing Unit, or CPU for short. If the computer were a person, the CPU would be its brain. It's the part that does all the heavy thinking, the calculating, and the decision-making. Every single time you ask your computer to do something, whether it's opening a program, think of the CPU as a master chef in a super-fast kitchen. The ingredients are data, and the recipes are instructions from the software you're using. When you want to open a photo, the instruction "open this picture" is sent to the chef. It follows a cycle that happens over and over again at incredible speeds. Fetch, decode, and execute. Now that we've met the brain, the CPU, let's talk about its trusty sidekick, the computer's short-term memory. This is called random access memory, or RAM. If the CPU is the chef, then RAM is the countertop or workspace right next to the stove. It's a super-fast type of memory that holds all the data and instructions the CPU is actively using right now. When you open a program like a web browser or a game, it gets loaded from your long-term storage into the RAM, so the CPU can access it instantly. Think about it this way. Imagine you're doing your homework. You have your textbook, your notebook, and your pencils all laid out on your desk. That's your RAM. It's everything you need right in front of you for quick access. Your bookshelf, where you keep all your other books, is your long-term storage. One key thing to remember about RAM is that it's volatile. That's a science word that means it only works when the computer is turned on. As soon as you shut down your computer, everything on the RAM countertop is wiped clean. We've covered the brain, which is the CPU, and the temporary workspace, which is RAM. So, where does everything go when you're not using it? Where do you keep your photos, your music, your games, and all your saved documents? That's the job of the computer's storage drive. Think of it as a massive, super-organized filing cabinet or a giant library. There are two main types of storage drives you'll find in computers today: the hard disk drive, or HDD, and the solid-state drive, or SSD. An HDD is the more traditional type. It works kind of like a tiny high-tech record player. The newer kid on the block is the solid-state drive, or SSD. These are much faster because they have no moving parts at all. So, whether it's an HDD or an SSD, the storage drive is where your digital life is stored. Your operating system, the main software that runs your computer like Windows or macOS, lives here. All your applications, from your word processor to your favorite game, are installed here. Okay, so we have a brain, which is the CPU, a workspace, that's RAM, and a filing cabinet, which is storage. But how do we tell the computer what to do in the first place? Well, that's where input devices come in. The most common input devices you use every single day are your keyboard and your mouse. Every time you press a key, you are actually closing a tiny electrical circuit underneath that key. A microphone is an input device that captures the sound waves of your voice and turns them into a digital signal the computer can understand. Even the touchscreen on your phone or tablet is a sophisticated input device, sensing the location of your finger to register taps, swipes, and pinches as commands. We've learned how to talk to the computer with input devices, but how does the computer talk back to us? This is the job of output devices. The most important output device is, without a doubt, your monitor or screen. After the CPU has processed all the data for what you should be seeing, it sends that information to a special component called the graphics card. The monitor itself is a grid of millions of tiny dots called pixels. Each pixel can be told to light up with a specific color, red, green, or blue, at varying intensities. But we don't just see the computer's work, we often hear it too. Speakers and headphones are essential output devices. The speakers contain a small electromagnet that vibrates a cone or diaphragm back and forth according to this signal. And it doesn't stop there. A printer is another classic output device. It takes a digital document or image from your computer and creates a physical copy on paper. So we've met all the key players on the team: the thinking CPU, the speedy RAM, the vast storage drive, and the input-output devices that let us communicate. Now let's see how they all work together in a beautiful high-speed symphony. Let's follow a single, simple action from beginning to end. Imagine you want to write a school report. The first thing you do is double-click the icon for your word processing program. What happens in that split second? First, your input device, the mouse, sends a signal to the computer. It tells the CPU, "Hey, the user just double-clicked on this specific spot on the screen." The CPU now has its mission. It sends a command to the storage drive, the big filing cabinet, saying, "Find the files for the word processing program and get them ready." Next, the storage drive locates all the necessary files for the program. It then copies that information from the slow, long-term filing cabinet and loads it into the fast, temporary workspace, the RAM. The CPU can now access all the program's instructions and data from the RAM almost instantly. The CPU, following the program's instructions, sends information to the graphics card. It says, "We need to draw a blank white page with a blinking cursor on the screen." Suddenly, the program window appears on your screen. Now that we have a better idea of how they work, it's amazing to stop and think about just how many places we find computers in our daily lives. They aren't just the boxes on our desks or the laptops in our bags anymore. Think about your morning. The digital alarm clock that woke you up is a simple computer. The microwave you use to heat your breakfast has a small computer inside to control the cooking time and power level. When your parents drive you to school, the car they are driving has dozens of computers. They control everything from the engine's performance and fuel efficiency to the anti-lock braking system that keeps you safe. When you go to the grocery store, a computer is at the heart of the checkout process. The barcode scanner is an input device that reads the black and white lines on a product. Computers also manage the store's inventory, automatically ordering more cereal when supplies run low. Even our fun and hobbies are powered by computers. The video game console in your living room is an incredibly powerful computer optimized for creating stunning graphics and immersive worlds. The special effects you see in blockbuster movies are created using massive networks of computers working together, a process called rendering. The systems that allow you to stream movies and TV shows instantly rely on powerful computers called servers to store and send that video data to your device over the internet. So, at the end of the day, what does it all boil down to? It's this. A computer is a machine that follows instructions. That's its one and only superpower. But it can follow them with incredible speed and perfect accuracy. Let's consider one final simple example. You're on the internet, and you click a link that says, "Show me pictures of cats." What are you really doing? You are giving the computer a command. Your click tells the CPU to follow the instructions associated with that link. The CPU, using the web browser program loaded in RAM, sends a request out over the internet to another computer, a server, where the website is stored. The data for the cat pictures travels back across the internet to your computer. Your CPU receives this data and, following the instructions from your web browser, tells the graphics card how to arrange the pictures on your screen. And poof, a screen full of adorable cats appears. Every part of the computer's team, the CPU, RAM, storage, and I/O devices, work together to follow that one simple command. They fetched data, processed it, and presented you with the result you wanted. It's a worldwide multi-computer collaboration that happens in seconds. And that is the true magic of computers. So the next time you use a computer, think about the amazing team of components working together at lightning speed, all to follow your command. Science is all around us.